Alright, so we're going to do a trig substitution integration problem here. The integral is the fraction x over the square root of x squared minus 1. So that is going to be the type where we have the square root of x squared minus a squared. So we're going to use that to set up our trig substitution. So pulling some things together here, looking at this, our x is going to be x, our a is going to be 1. So we're just going to go ahead and set that up. So our square root of x squared minus 1 will be tangent theta. Pulling in for the other things, our x will be secant of theta Let's get all our color coded well here. And the only other thing we have to replace is dx, which will be secant tangent d theta. And I like to draw my triangle. Usually that would probably be first, and maybe I wouldn't do everything in the same order here, but when you get used to having the same substitutions over and over, it becomes pretty simple just to pull those substitutions in. Okay, so let's take all of our substitutions and put them in. So we'll replace the x with secant theta. We'll replace the square root function with tangent theta, and we'll replace the dx with secant theta tangent theta d theta, and then we can come back and reduce. So we'll have a tangent cancel out, and basically we'll be integrating secant squared of theta. That's nice. Secant squared of theta integrates just to be tangent. So we'll have tangent of theta plus c. But we don't want to leave it in terms of theta, so we go back to our triangle, and tangent is opposite. So that is square root of x squared minus 1 over adjacent, so that's plus 1, over 1. So tangent is square root of x squared minus 1 over 1 plus c. Of course, I don't need that 1 on the bottom, so I'll just rewrite it as square root of x squared minus 1 plus c. And there it is in terms of x. So that was not very difficult. Good job.